Hello, discrete math fans. We're going to talk about graph theory. Now, graph theory goes back to the 1700s when the great Swiss mathematician Leonhard Euler solved a puzzle. And by the way, very important that we make note, this name is pronounced Euler. It is not pronounced Euler. It looks like it might be Euler. It is Euler. So please make sure you pronounce his name correctly. He is one of the greatest mathematicians that ever lived, so let's have some respect for the great Euler. Anyway, Euler solved this puzzle. The town of Königsberg was built at a point where two branches of the Pregel River came together. So inside there was an island and some land along the riverbanks. These were connected by 7 bridges. And the puzzle is it possible for a person to take a walk around town, starting and ending at the same location and crossing each one of the 7 bridges exactly once? This is a map of Königsberg. The bridges are highlighted in red. And so what you should see here is there's this island in the middle, and the river cuts through in 2 ways. Euler translated this problem into a graph theory problem. For the purposes of solving this puzzle, the map of Königsberg can be identified with a graph. So this object is a graph. The 4 vertices represent the various land masses that are separated by the river, and the 7 edges represent the 7 bridges. By representing Königsberg and its bridges with this graph, we can translate Euler's problem into a new problem involving graph theory. Is it possible to find a route through the graph that starts and ends at some vertex and passes through each edge exactly once? As an alternative formulation, we could say try to trace the graph. Start your pencil on one vertex and trace over the entire graph. We must start and end at the same vertex, and we must trace over each edge exactly once. You should take a moment to try this out for yourself. Pause the video now, draw out that graph, and see if you can trace over it, starting and ending at the same vertex and following each edge exactly once. Now, it turns out to be impossible. And by the way, if you feel like you've actually done it, go back over the requirements again. It's actually impossible to do. Make sure, for instance, that you start and end at the same vertex. We'll see later on why this is impossible. Okay, that's all for now.